Hi, welcome to Nepal Digital Education. Today in this video series, we are going to cover numericals of energy, work and power of class 8. Let us look at the problem first. The force applied on a body of mass 5 kg is 20 Newton. If the body moves through a distance of 12 meter, calculate the amount of work done. Before solving this all numerical problem, first of all, our topic is work, energy, power. So, first of all, work. What do you understand by work? Work means work. Numerically, work is given by force into displacement, or we can say that work equal to force into distance in the direction of force applied. So simply we can also say that work equal to F into D, and we can define work is the product of force and the displacement. And here our topic is energy and power. Energy means capacity of doing work, and energy is also two types: kinetic energy and potential energy. Kinetic energy means energy possessed by a body due to its motion, and potential energy means energy possessed by a body due to its position. If an object is at position, it's some at height, so in this case a body possesses potential energy. Suppose a bird is flying in the sky, or water is running in the river, so in this case energy possessed is kinetic energy. So kinetic energy means when a body is in motion, it possesses kinetic energy. When it at position at rest, then body possesses potential energy. And work means force into displacement, or force into distance in the direction of force applied. And power is, and also power is given by work done upon time taken. And we can also define power means rate of doing work is called power, or mathematically we can express power equal to work done upon time taken. And we can express mathematically kinetic energy equal to 1 by 2 mv square, where m is the mass, v is the velocity. And potential energy equal to mgh, mass, acceleration due to gravity, and height. And always body when is in motion, then it exert kinetic energy. When the body is at rest or at position, then it exert potential energy. Let's move to the problem first. In this problem, the force applied on the body of mass 5 kg. So mass is given is 20 Newton. This force is given. If the body moves through a distance is given. Calculate the amount of work done. So in this problem, we have to find the work done. So before solving the numerical problem, first step we have to write the given whatever given in the question. Like in this question, we have mass is given 5 kg, force is given 20 Newton, and distance is given 12 meter, and we have to find the work. And we know that work means force into distance in the direction of force applied. So we know that force means mg, but we have given force and mass is also given. We have to find the work means F into D, but it is not necessary. Just by we have given force, that is 20, and distance is given 12. In this way 12 to the 24 and 1 0. This is the required work, and we know that the unit of the work is joule. So 240 joule. This is the required work. This is the amount of the work done. Let us move to the next problem, problem number 2. In this problem, We have an object with mass. Here mass is given, lifted to a height is given. What is the amount of work done in this case? In this case, what is the work done? An object mass. So first of all, write the given. Mass is given. Mass is given 500 work, and height is given 100 centimeter, and we have to find the work done. So first of all, this is given and we have to change in the SI system. So height is height means the SI unit of height is meter, but it is given in centimeter. So we know that 1 meter equal to 100 centimeters, so it become 1 meter. And we know that here in the case of height, we can use, in the case of work done, in this case work done equal to potential energy mgh, because work done is numerically equal to energy, because here we know that the SI unit of work is joule and energy is also joule, so we can equate work with the energy. And in this case, object is at height. When there is height, so in height there will be potential energy, because potential energy means position or height. When a body is at height or position, then there will be what? Potential energy. So your mass is given 500 and g is not given, or we can use acceleration to gravity 10, and height is given 1. Just solve it. We get 5000, and work means joule. Yes, I of work in joule. So this is the required amount of the work done in this case, that is 5000 joule. Body with mass 500 kg lifted to a height of 100 meter. So in this case, height case, we use work done equal to potential energy, because potential energy means when a body is at case of the height, means this body of 500 kg and height is 100 centimeter. In this case, work done is equal to potential energy. So this is the required work, that is 5000 joule in this case. Let us look at the next problem number 3. In this problem, what work is done in pulling with a block 20 meter horizontally when 80 Newton effort is applied on it? So in this case, first of all, write whatever given in the question. So what work is done? So in this problem, we have to find the work in pulling a block of 20 meter horizontally. 20 meter means this is the distance. Distance is given 20 meter horizontally when 80 Newton effort means it is given force is given. Effort means force applied. So it is force. So what will be the work? So we know that work F into D, and we have force 80 and distance 20, then 8 to the 1600 and joule. This is the required work. That is 1600 means 1600 joule is work. This is the work in pulling a block of 20 meter horizontally when 80 Newton effort is applied on it. Let us look at the next problem 4. In this problem, we have to calculate the kinetic energy. In this problem, we have to calculate the kinetic energy of the body if its speed is given and mass is given. So first of all, write the given speed. V is given 100 meter per second. Mass is given 120 gram. So mass, we have to change mass. We know that the unit of the mass is kg, so but it is given in gram, so we have to change in kg. So we know that 1 kg means 1000 gram. If we have to change kg to gram, then just by multiplying with 1000 we get the value. But in this case we have to change gram to kg. So just divide with 1000 and we get the value. So 120 divide 1000, then it become, divide 120 divide 1000, it become 0.0.12 kg. Yes, this is the mass, and we have to calculate the kinetic energy. Kinetic energy, we know that kinetic energy means 1 by 2 mv square. V means velocity. So put the value 1 by 2, mass is given 0.12, v means velocity. Velocity is given 100. Velocity is 100. So when we multiply 0.12 into 100 square means 100 into 100, then divide with 2, then we get the value, that is, yes, here in this problem we have speed is given, sorry, here in speed there is 110, speed is 110, here 110, speed is given 110. This question is mistake. Yes, correct, here 110, velocity is given 110. So 110 into 1, just multiply it and divide, we get the value 726. Kinetic energy means joule. This is the required kinetic energy. In this question there is mistake, no, 100 not 100, here velocity is given 110. This is 110 meter per second. So the kinetic energy become 726 joule. Let us look at the next problem, problem number 5. In this problem we have to find the mass, means the kinetic energy of the body. Kinetic energy is given. If it is speed is also given. What will be its mass? In this problem we have to find the mass. So kinetic energy is given, kinetic energy is given 200 joule. Speed is given v 12 meter per second. What will be its mass? So we know that kinetic energy equal to 1 by 2 mv square, and we have kinetic energy 200, 1 by 2, mass, we have to find the mass, v is given 12 square. 200 equal to, this means 1 into m into 12 into 12 divide 2. 2 is in division. Just by doing cross multiplication we get m 12 into 12. This 2 2s are 4, 0 0. This 12 into 12 is in multiplication, so it comes in division. 12 equal to m. So solve it and we get m equal to mass equal to 2.77 kg. The unit of mass is kg. So this is the required mass, 2.77 kg. Let us look at the next problem, problem number 6. In this problem, a man with mass, here mass is given, climbing up a staircase having 30 steps, each 10 centimeter height in 10 seconds. Calculate his power. We know that power equal to work done upon time taken, and we know that work means F into D upon T, and we know that force is given by m g and dt. So in this way we can find the power. We have mass is given 60 kg, mass is given 60, and having 30 step, number number of number of steps equal to 30, and each of 10 centimeter height. 10 centimeter height means total height is 30 into 10, because number of step is 30 and each step is 10 centimeter. Each step is 10 means 30 step means 30 into 10 means 300 centimeter. So 300 centimeter, when we divide with 100, then change into meter, so it become 3 meter. And time is given, 10 second, and we have to calculate the power, and we have to find the power. So power equal to what? We know that power equal to work done upon time taken. Work means force into distance upon time, and again force means mg and dt. In place of force we use this m into g. Then mass is given 60, mass is 60, g is 10. We know that if there g means acceleration due to gravity, and the value of g is 10. And what is d? D means distance or height. Yes, same thing, distance or height is same thing. And d, the value of d is 3 meter. So d become 3, and time is given 10 second. So 10 cancel, 6 3s are 18, 0. And power, this is the required power, and we know that the unit of the power is watt. So power, this is the required power, that is 180 watt. So a man with mass 60 kg climbs up a staircase having 30 steps, each of 10 centimeter height, in 10 seconds. Calculate his power. So his power become 180 watt. In this problem, this is the main step, that is 30 step each of 10 centimeter height, means height or distance. We can calculate height and distance from this, means each step is 30 centimeter. 30 step, each step of 10 centimeter, each step of 10 centimeter means each step is 10 centimeter. So 30 step means 30 into 10, so it become 300 centimeter. 300 centimeter means 3 meter. So in this way we can solve Let us look at the next problem, problem 7. In this problem, a man does 9,000 joule work in 20 seconds. What is his power? So in this problem, work is given, time is given, and we have to find the power. So work is given 9,000 joule, time is given 20 seconds. What is his power? We know that power means work done upon time taken, and work is 9,000. And time is given 20 seconds. So here 20, just calculate it. 9,000 divide 20, 450, and the unit of power is watt. So this is the required power, 450 watt. This is the required power of the man who does 9,000 joule work in 20 seconds. Let us look at the next problem, problem 8. In this problem, if a body of mass, so mass is given is placed at the height is given 50 meter from the earth's surface. What will be its potential energy? So we know that potential energy equal to mgh. Potential energy equal to mgh. When a body is at, in the case of position or height, then it possesses potential energy. So in this case, a body of mass, so mass is given, so here mass is given 500 gram and height is given 15 meter. So this is given, but mass is given in grams, so here we have to change in kg. Sorry, 500. So when we divide with 1000, so it become 0.5 kg. This is the required mass and this is the height, and we have to find the potential energy. We know that potential energy given by mgh. Mass is given 0.5 and g is 10, height is given 15. Just calculate it. 0.5 into 10 into 15, it becomes 75 joule. The unit of energy is potential energy, joule. So this is the required potential energy, that is 75 joule. Let us look at the next problem, problem 9. In this problem, an electric bulb consumes 3200 joule of energy. This is energy is given in 4 minutes. Calculate its power. We know that power is given by work done upon time taken. So we have work 3200 joule, and time is also given 4 minutes, and here we have to change in second. Just multiply with 66 for 24 0, it become second. No, time is given in minutes, so we know that the SI unit of time is second, so we have to change in second. Just multiply with 60, we get the value in second, because we know that 1 minute equal to 60 second. Yes, we have to find power. So power is given by work done upon time, and work done means 3200 and time is given 240. Just calculate it. 00 cancel. Yes, if you calculate 3200 divide 240, it become 13.33. And the unit of power is watt. This is the required power. Let us look at the next problem, and this is the last problem, problem number 10. In this problem, a crane can lift a load. So load is given here. Load is given to a height is given, time is given. Calculate the power of the crane in watt, kilowatt and horsepower. We have to calculate the power in watt, kilowatt and power. First of all, we know that power means rate of the doing work, means work, and mathematically it is given by work done upon time taken. So first of all, write the given. Load is given here. Load, weight of an object. A crane can lift a load of 4500. 45,000. Sorry, here load is 45,000 Newton. So force is given. Here force is 45,000 Newton to a height. Height is given. Height is given 20 meter in 10 seconds. Time is also given. Time is given 10 seconds. Calculate the power. So we know that power is given by work done upon time taken, and we know that work done means F into D upon T, and we know that work equal to force into displacement or distance in the direction of force applied, and we have the value of the force, that is 45,000 into D, and D means distance or height, and we have distance, height 20, and here time is given 10. So just calculate it. When we calculate 45,020 divide 10, then it become 90,000. 90,000, and the unit of power is watt. This is the required value of the power, that is 90,000 watt. But we have to find the power in kilowatt also and horsepower also. So in next case we have to find the power in kilowatt. So we know that 1 watt 1 watt means 10 to the power minus 3 kilowatt. So here power is given 90,000 watt. So we have to change in kilowatt. We have to change here watt to kilowatt. So power is 90,000 and we have to change in kilowatt. So when we multiply with 10 to the power minus 3, then it become 90,000. 10 to the power minus 3 means 1 by 10 power 3 means 0. Then it becomes this 30 cancel and it becomes 90 kilowatt. 90 kilowatt. Again in next case we have to find the power in horsepower, and we know that 1 horsepower equal to 746 watt, and it is also equivalent to 750 watt. So we have power 90,000, but we have to change in horsepower. So 90,000 watt. When we change watt to horsepower, then 1 horsepower means 746 watt. So watt to horsepower. So our power is 90,000. Power is 90,000 watt, but we have to change in horsepower. So we can easily change into horsepower. Yes, in this case we have power 90,000 watt and we have to change in horsepower. So 90,000 divide 746. When we divide with 746, then it changes into horsepower, that is 120.6, and power, the unit of power is watt. But when we divide, yes, this is the required power in this is the required power in horsepower. This is the required horsepower. We can also change, like we have 90,000, and we can also divide with 750. When we divide with 750, then it will come 120 horsepower. This is also answer, this is also answer. We can write anyone, both are right.